Step 2, you remember the first 4 structures are just sugars. We're going to take that same alpha-D glucose 6-phosphate and we're going to do the fructose equivalent because now we're up to the F. We're going to draw the fructose isomer of glucose 6-phosphate, and that would be alpha D fructose 6-phosphate. Our C2 has the OH. We reverse the direction of the 2 intermediate OH groups, and here's our C6, so there's our phosphate. Alpha D fructose 6-phosphate coming from alpha D glucose 6-phosphate. We don't have to worry about adding any phosphates because we're just rearranging it to make it an isomer. Step 3, G we've done, add a phosphate, fructose equivalent. So our next step is going to be to add a phosphate. So let's redraw our alpha D fructose 6-phosphate, H2OP, and we're going to add a phosphate. Let's make sure that second step is a two-way, and we're up to step 3, so I'm going to make that a one-way reaction. Where are we going to add the phosphate? We're going to add it to C1 because our next structure is alpha D fructose 1,6-bis phosphate. We're going to redraw this structure we just had, only this time we're going to add a phosphate group. The phosphate group is going to come from ATP. So in order to get a phosphate group in here, we're going to lose that hydrogen. And there it is now, right on C1. Everything else stays the same. That's step 3. Now let's look at step 4. We've done the glucose, add a phosphate, fructose, add a phosphate. So now we're up to the S in GAFAs, which stands for split. We're going to split our compound into 6-carbon compound into 2 3-carbon compounds. So let's go ahead and redraw the compound we just had. Fructose 1,6-bis phosphate. I'm just going to abbreviate here. We're going to split it. We're going to have our dihydroxyacetone phosphate, DHAP. Dihydroxy means 2 hydroxy groups. Acetone telling us it's a ketone in the middle. And here's our phosphate telling us to put a phosphate on C3. The other compound we're getting when we split this is glyceraldehyde 3-phosphate. Glyceraldehyde derives from glycerol, so it's got 3 carbons. Glyceraldehyde 3-phosphate. Now the aldehyde is going to be on the lowest possible carbon, which is always going to be C1 for an aldehyde. So here's our aldehyde on C1 deriving from glycerol, so we have our OH in the middle. Now it's telling us, yeah, we would have a OH on C3, but we want you to add a phosphate in there too. So instead of writing an H here, we're going to put a phosphate group. Step 5 is simple enough. We've done G, add a phosphate, fructose version, add a phosphate, split. The C in chef is going to stand for convert. We're going to convert DHAP to glyceraldehyde 3-phosphate. So let's redraw our DHAP. 1, 2, 3. Dihydroxy acetone phosphate. Here's our glyceraldehyde 3-phosphate. Oh no, I want to draw dihydroxyacetone phosphate. And we're going to just redraw glyceraldehyde 3-phosphate, which we already know how to draw that. 1, 2, 3. Here's our aldehyde. Aldehyde 3-phosphate. So at this point, we have the glyceraldehyde we made from the split, but now we've also converted the DHAP. So now, really, from this point on, where we hit glyceraldehyde, we have two of every compound in glycolysis. You should note that glyceraldehyde 3-phosphate and DHAP are isomers, and that's going to help us later on when we name the isomers. Step 6. We've done our glucose, add a phosphate, fructose, add a phosphate. We've split it into DHAP and glyceraldehyde 3-phosphate. And we just now converted, that's the C in chef. So now we're up to making bis 8. And you'll remember that stands for a compound that's bis something ATE. We left off at glyceraldehyde 3-phosphate, so let me draw that again. Glyceraldehyde, I'm going to abbreviate, 3-phosphate. Now we want to turn that into 1,3 bis phosphoglycerate. What do we know from looking at the name of this compound? Well, it's a glycerate, so it's got 3 carbons, and we know there's an ATE, so we're going to go ahead and add a C double bond O. But since we have to add a phosphate in, I'm going to draw it this way, so we can put our phosphate on. That's our C1. Well, it's telling us, the name is telling us we have 2 phosphate groups, 1 phosphate on C1 and 1 phosphate on C3. So let's put our other hydrogen, our other phosphate group there. Since this is big step 6, we know our phosphate doesn't come from ATP as it does for all other steps in glycolysis. It's going to come from HPO4 2-. That's where this other phosphate is going to come from. 3 more steps. We're up to step 7. Let's redraw bis, which means 2-phosphoglycerate. Oops, I didn't finish my glycerate here. Put an OH. Let's redraw our bis-phosphoglycerate. Notice the numbers are now preceding the name, 1,3-bisphosphoglycerate, buys 8. And now the chef is going to buy 832 peppers. The 3 is telling us we have 3-phosphoglycerate. So we're going to lose one of our phosphates, and of course, given the option, which it does have the option, we're going to make ATP with that. But let's draw our glycerate. Now we're going to be losing that phosphate group on carbon number 1. Because we see in the name of this one, the phosphate is now just on carbon number 3. So that gets to stay. What are we left with? Just the ATE, because we don't have anything on carbon 1 that they're telling us about. Step 8 is simple enough. We're going to go from a 3-phosphoglycerate to a 2-phosphoglycerate because we have 832 peppers. Let's redraw the 3-phosphoglycerate. Phosphoglycerate, and of course we're going to 2-phosphoglycerate. I hope you're drawing along with me all through this. And 3-phosphoglycerate, 2-phosphoglycerate are of course isomers. So we're just going to switch these two groups. Start with 3 carbons. It's got the ATE ending, so we have the carboxylate ion on C1. That makes this C2, and that's where our phosphate's going to go. Voila! 3-phosphoglycerate, 2-phosphoglycerate. 2 more steps to go. So step 9, let's see what we've done so far. GAFA, GAFAs, chef, buys 832 peppers. So step 9, we have 2-phosphoglycerate. Let's redraw that. Phosphoglycerate. And as we know from our little sentence up here, we're going to go into phosphoenolpyruvate. I'm going to abbreviate. Well, no, I won't, because I want you to see how you make it. Phosphoenolpyruvate. You remember an enol has this form, a CH2, carbon double bonded to another carbon, and then an O something, and the something we know from the name is phosphate. Phosphoenolpyruvate, so we know the bottom is a carboxylate ion. And this brings us ultimately to our final step in glycolysis, step 9, where we go from PEP, this is a one-way, to pyruvate. So we'll redraw phosphoenol pyruvate. And we're going to pyruvate, which is pyruvate. Note